Okay, multiple linear regression model is where you have two or more independent variables trying to predict for one dependent variable. So my two independent variables are weight and age, and we're trying to use those to predict a person's blood pressure. Okay, just a random data set I made up. And what you're doing is you're calculating a slope, so 1.23x1 plus, let's do subtract. That's like a multiple linear regression model. That's what it looks like, where x1 is your first column variable, x2 is your second column variable, and this is the y-intercept. Okay, so you're creating an equation, and that equation is trying to predict the y values based on these given x values. And so we have a mathematical formula to give us the equation that minimizes the error, for those predictions with our given data set. Okay, so in Excel, it's kind of tough to do, so we're just going to use a free online resource. I just searched multiple linear regression significance calculator. So I got to have the words multiple in there because there's more than one. Linear because we're just talking about a straight line type of regression. And then we want to test for the significance to see whether a multiple linear regression model is statistically significant. And then I type the word calculator because I don't want to do it by hand. That's the whole point of having computers here. If you're in a professional setting, you're just going to have to learn whatever software they give you, so there's no point in forcing us to pick up a new piece of software and learn all the details of it. Okay, so I just copied and pasted my data in here. Make sure you get the y value right. That's the one that really matters. And then you want to keep track of which one's x1 and which one's x2. So weight is x1, age is x2, y is my blood pressure because that's the thing I'm trying to predict. And so what comes out is a bunch of numbers. The big things you'll want to look for in a stats class are the p-values. This p-value is very low. That means this y-intercept, that's what the b is representing, is statistically significant. Okay, so the y-intercept is very helpful in making a prediction, this model says. But the y-intercept doesn't really have too much meaning. The y-intercept means when both x variables are 0, this is our prediction for blood pressure for a y variable. So when is your weight and age ever going to be 0, right? So the y-intercept doesn't have a lot of meaning in my data set. x1, this is for my data set, the weight. The p-value is above 0.05, so that means weight is not a statistically significant predictor for blood pressure. If the p-value is high, that means it's not, your data set isn't finding something new. It isn't finding something that helps make a prediction. Okay, so weight is not a statistically significant predictor. And then same thing for age. This multiple linear regression model had a high p-value for both the predictors. That means it's a bad linear model. It's not good at making predictions for blood pressure. If you got a low p-value for just one of these, then you could say, hey, this one is statistically significant, this other one isn't. Maybe we'll just drop this other variable that has a high p-value because it's not helping us make predictions. And that's it. That's the basics. You want to look at the slopes of those regression lines, and then researchers would say, okay, this one has a high p-value. Let's drop it. Let's run the multiple linear regression model again, see if we get a better fit.